Hi, it's Miss Miles. Today we'll be factoring polynomials. In this first example, it is a trinomial because it has three terms. And if we were asked to factor this trinomial, we would look for a common factor that we could take out of all three terms. And so that common factor is 4ab squared. And now we would look at the trinomial inside the parentheses. Is there any other common factor I can take out? Or can I factor that further? I cannot. But I might rewrite it so that the a squared term is first, then the a term, then the constant. And so that's called factoring out a greatest common factor. Now you'll have a trinomial very often to factor of this form, where the leading coefficient is 1. That's the number multiplying the x squared term. And this is what you think to yourself. What two numbers multiply to equal negative 18 and add together to equal negative 3? So that's negative 6 and positive 3. And therefore we write our factored form as x minus 6 times x plus 3. Always check using FOIL or double distributive or box that your factored form multiplies back to equal the given trinomial. So that's when you have a trinomial with a leading coefficient of 1. In this case, the leading coefficient is something other than 1. And so in this type of example, I like to use the box strategy. You make a 2 by 2 box. The x squared term goes in the top left, the constant term goes in the lower right. You multiply the 3 times 4 in this case together to get 12. And you think, what two numbers multiply to equal 12, but add together to equal negative 8? So I want two negative factors of 12. And negative 6 times negative 2 equals positive 12, but when you add them together it equals that negative 8. So those are the two that I want to put along the diagonal, followed by the x. And I'm going to look at my top row now, and I want to factor out a common factor. That's 3x. Now you think about your lattice multiplication. And I'm looking at that 3x, which is in red, and I think 3x times what equals 3x squared. And now I think x times what equals negative 2x. And negative 2 times what equals positive 4. And now I'm finished. I just write those red terms as binomials and make sure you check by multiplication that these factors are correct. And so that's when the leading coefficient of the trinomial is other than 1. Now we have special products to consider. In this example, there's nothing I can factor out of both terms, and it's not a trinomial, it's a binomial. The first and the second term are both perfect squares, and there's a subtraction sign. So this is called the difference of two squares, and it factors this way. Don't forget you need a minus and a plus for your signs. You take the square root of 16x squared, and then the square root of the second term, and we're finished. In this example, it is a trinomial, but it's a special kind of trinomial. It's called a perfect square trinomial because the first and third terms are perfect squares. And if you take the square root of each of those terms and you double the product of those square roots, you'll get the middle term. So these problems factor this way. The square root of the first term goes here. The square root of the third term goes here. And always be sure that the product of those two doubled will give you the middle term. Also be sure that your sign, the subtraction sign between 2a and 7b, matches the sign of the middle term. So that's a perfect square trinomial. Okay, one more type is factoring by grouping. So you always start by asking, is there something I can factor out of all of the terms? There is not. So then the next thought is, can I group these terms two at a time and then factor the groups? Yeah, even if I keep them in this exact order, I can factor a 3x squared out of the green group and a negative 8 out of the red group. And do you notice how the expression in the parentheses matches? So now what I want to do is factor that expression out, right? So like undoing the distributive property. And what I have here is the factored form of the original polynomial. You always just have to double check that there's no common factor in either binomial. And then you know it's fully factored. Okay, so I thought it might be a good idea for you to try some examples. Now, I can give you a hint on what type of polynomials these are if you need a hint. Otherwise, hit pause now, and when you're finished, we can double check that we agree. Okay, so here are your hints. If you use these strategies, you'll have luck factoring these polynomials. Again, hit pause, and when you're ready, we'll double check together. And here are your answers to the practice problems.